Hi, I'm Bill. I'm the operations manager at the generator. Welcome to the metal shop. So whenever you work in here, I need help by cleaning up something that you didn't work on. So, work over here, clean up over here, clean up over there too. Okay, so I'm gonna check you guys out on one of these gas MIGs over here. So this is our welder lineup. This is our TIG, 2 MIGs and a stick. So really important things that you should know. The tank should be turned inwards so that the regulator is protected from slamming up against the wall. Your regulators need to stay relaxed. So this regulator is not relaxed. Basically that this screw is unscrewed all the way and it's loose. You want your regulator relaxed when you open this tank. This tank comes fresh at about 2,000 psi. Common things that happen to the regulators is the regulator is engaged and you open the tank and 2,000 pounds of pressure hit the diaphragm and the diaphragm ruptures or gets a small tear in it or ruptures. Regulators are about $150 to $200 a piece. I'm going to check you guys out on the 251 right here. Both of these machines are gas MIG. This is the beefier, more plug and play machine. This one works good too. They have different settings, different control knobs, but ultimately they do the same thing. Okay. In the off season, I like to run flux core through this machine. So then I have a gas and a flux machine running. There are 4 spots to plug a welder in the room. There's one right by the door behind the yellow grinder. There's another one right down the wall by the fan switch.
Yep.
There's another one right behind that red sandblaster.
Okay.
And there's another one right in this corner where all the welders are. This goes in here. So we have the machine plugged in. We have the regulator relaxed. Your tanks, you open the valve all the way. It seals on the bottom and it seals on the top. You're gonna have 2 gauges here. If you come around, look. You've got tank pressure on the tank side, and you have operating pressure on the operating side.
Is that line pressure?
Yeah, this will be line pressure.
Okay.
So line pressure in this room is 18 CFH. And it says that inside the welder as well. That's another sign of a regulator going out. It still works though. So we crank that up a little bit to 18. This is welding dip, so you dip the nozzle of the welder into this stuff and then you weld and it keeps your tip clean, but it's all goopy, so it picks up more dust and more slag and then makes like this gelatinous clump inside the nozzle rather than just a dusty clump. So it gets dirty the same way, but this time it's gooey instead of
Pros
being
and
dry.
cons, right?
Yeah. Well, I don't know what the pros are. I don't believe in this at all. But if you want to use it, go ahead. So you have 2 leads coming out of the welder. You have your torch and you have your ground. The ground is the big clamp. The best place to put your ground is the closest to where you're welding. The ground completes the circuit. So when you're welding metal together, you're fusing it with a short circuit.
Like putting battery terminals together.
Exactly, but in a more controlled manner.
Yeah, it's controlled.
So on the torch, you have the cone on the very end, pulls right off. If you twist it off, you'll most likely loosen up these fittings here, at which point, if you get an air gap back here, it'll start sucking atmosphere into the back of the torch, and then it'll kind of negate the effects of the gas on preventing oxidation of your weld. This is the tip. This is the most consumable piece of the welder besides the wire, which comes out here. Let's back it up to the machine here a little bit. So you have on-off on the bottom. and then you have voltage, and you have your wire speed. And your wire speed and your current are in the same knob. On the inside, here's our little chart. This is a really good go-to chart on where to start, where to put your settings for what kind of material you're working with. So this is probably like 18 gauge steel. So you're welding steel, and you're going to use solid wire, and the gas that we're using is a 75% argon, 25% CO2, and you find that right here on the tank. Wherever you find this little sticker, it's going to give you a more specific breakdown of your gas. So this is the gas we're using, and then it comes down to wire size, which looks kind of like an 030. And the dies are set for 030, and it looks thinner. Yeah. So if you can't look at it and tell what size it is, you can mic it with a micrometer. Put a micrometer on it and measure the thousandths of inch that it is. But I can look at that and tell you that that's an 030. Sometimes it'll tell you on the spool, so I can like, you want to be careful with this. This wire is like a giant spring. If I was to snip this, it would just, the whole thing would unravel and go all over the place. So if we look on the back of the spool, it tells us that it's 030.
That diameter?
Yeah. So it's 30 thousandths of an inch diameter. So we're well with 030, that's fine. It's big enough for what you guys are doing. So here we are, steel, solid wire, this type of gas. We're working with 030, and I say it's probably like, maybe it's like 16 gauge. These little marks are the actual thickness of the material.
Oh.
So if you don't have a way to measure it, you can just hold it up here and be like, oh yeah, it's kind of like that.
Okay.
And this happens to be 16 gauge. So then,
16 for sure.
roll down to 16, roll over from 030. It tells us to start at 16 and 210. So if we flip the machine on, it kind of gives a little startup. So the cool thing is that you can only get 16 on one dial, and you can only get 210 on the other dial. So that kind of breaks down the confusion there. This is voltage, this is current, and wire speed.
Well, it's, at least the MIG, they're a constant voltage machine, so basically what it does is it always keeps the voltage at where you set the voltage at, and then the wire speed just dictates your current. Unlike TIG, which is the opposite.
Okay, so you want to keep this shut while you're working. We got our gas on, we got our gas set. So we have our material, we have the welder set up for our material. We went through how to figure out how to set the welder up for your material. When you're done working on the machine, it'd be really nice to blow this out, get all this dust out of here. Maybe grab a rag and like shine it up. So this is generally how it needs to be put away when you're finished with it. The front cables here are loosely wrapped around the front. The electrical cable is unplugged and it's loosely wrapped around the tank. I'm gonna go ahead and spin that around a couple times, take up the slack in that hose.